Okay, in this video lesson, we'll be looking at the graphs of tangent and cotangent. This is first part of a three-part series. So we've learned in the past that tangent of theta is the relationship of the opposite over the adjacent, and cotangent is the adjacent over opposite. We transition to the variables x, y, and r. Tangent then converted to y over x, and cotangent converted to x over y. So if I look at the old school unit circle, which has all of our special angles and the associated coordinates for each one. So if I try to find the tangent of pi over 3, there it is there, and those are the corresponding coordinates, the x coordinate and the y coordinate. So if I wanted to find the value of tan pi over 3, I could simply divide the y coordinate by the x. When I divide, I get a solution of radical 3. So therefore, radical 3 is the tangent of pi over 3. If I wanted to find, say, cotangent of 5 pi over 4, well, there's 5 pi over 4, and those are the corresponding coordinates. And cotangent is x over y, so both the x and the y are negative radical 2 over 2. So when I divide those two values, I get an answer of 1. So therefore, the cotangent of 5 pi over 4 is simply 1. So what we're going to do is create an old school T-chart of all the values, or a bunch of the values, around the unit circle. And we hopefully will come up with enough points to actually plot and see what the graphs of tangent and cotangent look like. So I'll work my way around the unit circle starting at 0 pi. So if I want to find both the tangent and cotangent of 0 pi, there it is there, and there's the corresponding coordinates. So tangent y over x would give me 0, while x over y, 1 divided by 0, is undefined. We'll continue around the unit circle. So we'll skip pi over 6 and go to pi over 4. So we can find the tangent of pi over 4 using these coordinates. When we divide y over x, we get 1, and x over y, we also get 1. Continuing around the pi over 2, y over x is undefined, while x over y is 0. Continue around the 3 pi over 4. So to find the tangent and cotangent of 3 pi over 4, we'll be using these coordinates. Y over x, negative 1, x over y, also negative 1. Let's continue to pi. So to find the tangent and cotangent of pi, we'll be using these coordinates. Y over x, 0, x over y, undefined. Let's continue to 5 pi over 4. We can find the tangent and cotangent using those coordinates. When we divide them, y over x we get 1, and x over y we also get 1. Continuing to 3 pi over 2, so to find the tangent and cotangent, we'll use the coordinates 0 and negative 1. Tangent y over x, undefined. Cotangent x over y, 0. Couple more. Let's head to 7 pi over 4. So to find the tangent and cotangent, we'll use the coordinates radical 2 over 2 and negative radical 2 over 2. When we divide y over x, we get negative 1, and x over y, also negative 1. And finally, we get to 2 pi. The tangent and cotangent of 2 pi uses the same coordinates as 0 pi. So we'll still get 0 for tangent and undefined for cotangent. So now, just like back in algebra, when you first did T-charts, you had a few negative values, a few positive values, and 0. So we already did 0 and some positive values. So now let's consider going backwards in a clockwise direction around the unit circle. So if I wanted to go and find tangent and cotangent of negative pi over 4, that means go in a clockwise direction, pi over 4. If I went in a clockwise direction, that put me at 7 pi over 4, which is coterminal. So I would be using these coordinates. Y over x, negative 1, x over y, negative 1. Well, let's continue to negative pi over 2, which again takes us in a negative direction. That'll put us at 3 pi over 2. We're using the coordinates 0 and negative 1. Y over x, undefined, x over y, 0. Let's continue to negative 3 pi over 4. Continuing in a clockwise direction puts me at 5 pi over 4, or more importantly, the coordinates negative radical 2, over 2. When we divide them, we get 1. If we divide again, we get 1. Let's continue to negative pi, which puts me at pi. When we divide these two values, y over x, we get 1, x over y, undefined. Almost there. Negative 5 pi over 4 takes us to the same value as 3 pi over 4. We'll be using these two coordinates, y divided by x, negative 1, x divided by y, also negative 1. Taking us to negative 3 pi over 4, which is the same, negative 3 pi over 2, same as pi over 2. We'll be using these coordinates, y divided by x, undefined, and x divided by y, 0. Two more stops. Now, negative 7 pi over 4 puts us at the same place as pi over 4. When we divide the y and the x, we get 1, and we divide the x and the y, we also get 1. Last stop, negative 2 pi takes us to the same place as 0 pi. Using the coordinates 1 and 0, y divided by x is 0, and x divided by y, undefined. So when we look at these values, we see this pattern of 1s, 0s, negative 1s, and undefined. So let's see what that gives us. So if I begin to plot these points on two separate graphs, so the first one will be y equals tan theta, the second one y equals cotan theta. So when we look at, we'll start at the very bottom, negative 2 pi. So at negative 2 pi, the x coordinate, or the vertical coordinate, will be 0. So we can plot that first point. As we move to negative 7 pi over 4, the y value is 1. As we go to negative 3 pi over 2, it's undefined, so we're going to just skip that for right now. So let's keep going to negative 5 pi over 4. The value for my y is negative 1. For tan negative pi, the value is 0. As we move up, 1. Then we get to undefined again. We'll skip it, and we'll move on to negative pi over 4, which puts us back down at negative 1. So we begin to see this pattern occur. Next value puts us at 0, up to 1, then we're back at undefined. We'll skip. Next, back down to negative 1, then to 0, then to 1 again. Undefined, we'll skip. Back down to negative 1, coming up to the 0. So we begin to see some sort of pattern evolve. Well, let's look at cotangent. Start at negative 2 pi. First value is undefined. We'll skip that. Negative 7 pi over 4 puts us at positive 1. Next value puts us at 0, so we begin to fall in this case. And the negative 5 pi over 4 value is negative 1. Back to undefined, we'll skip. Negative 3 pi over 4 puts us back at 1. Next value at negative pi over 2 is at 0. The following is at negative 1. So we're beginning to see the pattern occur here also. Similar to tangent, but just a tad bit different. Undefined, we skip. Pi over 4 is at 1. Pi over 2 is at 0. 3 pi over 4 is at negative 1. Skip it at pi, undefined. Back to the 1, then to the 0, then to the negative 1. Last value, undefined. So let's see what we got so far. This is what we have for tangent. These are the points that we've plotted. What we're now going to do is take a look at these undefined values. First undefined value that we're going to look at is just the pi over 2. And whatever happens at pi over 2, we'll assume also happens at all those other values that were undefined. So we'll consider pi over 2 as an actual number. So we put that in the calculator, it'll give us about 1.57, etc. So we're going to consider what happens as we get closer to this value from both the left side and the right side. So imagine we're putting this value on the number line. To the left of 1.5707, etc., is approximately 1.57, which is a little bit less than. And on the right side, a little bit more than. And what we're going to do is approach this value, this undefined value, from each side. So numbers getting closer, little closer, little closer. So each of those values are a little bit bigger than 1.57, but each time getting closer to that pi over 2. Same thing from the 1.58. A little smaller, approaching that pi over 2 from the right side. And so what we're going to do is determine the tangent of each one of these values to see what happens. Well, we already know the tangent of pi over 2 is undefined. So let's first look at the tangent of 1.57. Tangent of 1.57 is about 1256, so 1256, which is a very large number. So, oops, let's see, where's my wrong one? There we go. So 1256, a very large number. If I did the 5707, see what we get. Tan 1.5707 gives us 10,381. So the number jumped substantially. And if I continue to do this, found the tangent of each one, the values get extremely large very fast. If I did the same thing with the 1.58, so let's see what we get for that. Tangent of 1.58, tan 1.58, negative 108, about negative 109. So when I go back, negative 109. If I found the tangent of 1.571, tan 1.571, negative 4,900, probably 910. Very large, or I should say a tiny number. So it's getting small really quick. So the same thing is going to happen with these other two values. Extremely small, very fast. So what's happening at, with the last point we were able to find that gave us an actual value, the y was 1. And from there, the values got extremely large very fast. Inversely, here, this point was negative 1. And if we approached from the right, numbers got extremely small, extremely fast. The same thing. So what is happening is we have this imaginary borderline that the graph is getting closer and closer, but will never actually touch. This is called an asymptote. And so at each one of the undefined values, an asymptote will occur. So we can then presume that at each one of these high points, as you approach from the left, numbers get extremely large, extremely fast. And when you approach from the right, they get extremely small, very fast. And so we begin to graph what we have here. We begin to see this shape form. This is the graph of tangent. This is the shape it takes. And the same thing would happen with each one of these as they approach the different asymptotes. So this is the graph of tangent. So when we consider cotangent, the same thing is going to happen. At each one of these undefined values, we will expect to see an asymptote. Same thing is going to happen as we approach the asymptote. So when I approach from the right, values get extremely large, extremely fast. And when we approach from the left, extremely small, extremely fast. And so when we attempt to graph it, we get the graph of cotangent. So it looks very similar to tangent, but just a tad bit different. So what we've concluded then, the graph of y equals tan theta takes on this shape, or this graph, and this is the graph of y equals cotangent theta. They're very similar, but they have some unique characteristics that we will explore in the next video lesson.